Hello everybody. So we're going to continue with writing and solving linear word problems. So if you remember, this lesson builds on the previous lesson where I went over the first couple of examples. So remember your steps. Read the problem carefully. That's really, really important. Highlight keywords. Okay. Label your unknowns. That's so important for the more difficult problems. And then once you label your unknowns, write an algebraic equation. A lot of times you're going to be adding them together or subtracting them, depending upon the problem. The easy part is solve the equation. And then once you get your answer, read the problem carefully, because sometimes you take the answer and actually plug it back in to figure out what the question's actually answering. Okay? So we went over a couple examples in the last lesson. So here are the examples we went over last time. I'm actually going to review example 2. If you remember, it says John and Lewis played in the same basketball team, but John and Lewis are two variables, right? So we write down what they are algebraically. Combined, they score 34 points, so we know we're adding them together and saying they equal to 34. Lewis scored 8 points less than the number of points John scored. Since we don't know anything about John's points that he scored, that's going to be X, because we don't know anything about it. And since Lewis scored 8 points less than John, Lewis is going to score 8 minus X. So we've got to take 8 away from X. But we need to have 2X in the problem because this is Lewis's and that's John's representation. So we solve the equation. That's the easy part. Trying to go a little fast here. Add 8, divide by 2, right? And when you do that, you get X is 21. But then you have to say find number of points each person scored. So 21 goes in there. John scored 21 points. And we plugged the 21 in there. Lewis scored 13 points. Or you could subtract 21 from your total to get Lewis's amount as well. Just a quick review for you. And we also did example 3 there. It's 3 consecutive integers, so we let the first one be x, and the second integer was x plus 1. The third integer was x plus 2. We added those up and set it equal to that sum, which is 348. That's our first integer, that's our second, that's our third, because they're consecutive. And we reviewed this last lesson just to refresh your memory. When we solved the equation, we got 3x plus 3 equals 348. And when we subtracted 3 and divided by 3, we got x is 115. So don't forget to plug that back in. We have 115, 116, and 117. Okay? And the shortcut way was to divide it by 3. That gives you a roundabout point to guess. Not the answer, a roundabout point to guess. And if you guess some numbers around consecutive, around 116, 115 plus 116 plus 117 does work. All right, so there's your review. Let's go to example 4. So it says the sum of 4 consecutive odd integers is 104. Find the integers. Okay. Well, consecutive integers are in order. So that would be like 9, 10, 11, or 13, 14, 15, right? But they're odd. Well, let me write down some consecutive odd integers. We're not saying this is the answer. We're just writing down some consecutive odd integers. If you compare the next integer to the previous, what do you notice? And the answer is it increases by 2. So even though it's odd, it's still increasing by 2. And there's actually many ways to do this problem. One way is to actually use the algebraic definition of an odd integer. I'm not going to do it that way, but if you notice, odd integers increase by 2. So if we assume the first integer is odd, we can let that be x. Then the second integer would be x plus 2. The third integer would be x plus 4. And the fourth one would be x plus 6. Because remember, see how they're increasing by 2? And actually, if we're not using the definition of even and odd for integers, if you look that up, actually even and odd numbers, if you assume that the first number is even or odd, they would actually have the same pattern of increasing by 2, no matter whether they're even or odd. So again, this works because even and odd numbers consecutive both increase by 2. If I just show you another example, the previous number is increasing by 2 or the next number, is increasing by 2 from the previous. So that's why this works. So we could take those 4 integers that we labeled over here, where that was the first one, right? And we could add those up and set it equal to 104. So x plus 2 plus x plus 4 plus x plus 6, that equals 104. This is the first, the second, the third integer, the fourth integer. So now we just solve it, the easy part. We have 4x's, 4x, and we have a couple coefficients here, or I should say, not coefficients, excuse me, constants. Positive 2, positive 4, positive 6. We add those up, we get positive 12. So we subtract 12. We get 4x. I'm continuing down here. So we subtract there again. We get 92. Divide by 4. You might have to write that one out. Use your calculator. X is 23. Remember, we're not done. We're finding 4 numbers. But we can take that, and this is why labeling is so awesome. Plug it in right here. So the first number is 23. You don't really have to label them because they're just integers. Next one is 25. Next one's 27. Next one's 29. And just to check it to make sure, if you add all these up using your calculator, I guarantee you get 104. So that works. 23, 25, 27, 29. And also notice they're odd. So we know we did it correctly. Now again, there's another way to do that problem using the definition of odd numbers. I'm not going to get into that because this way works for even and odd numbers. But some people like to guess and check strategy, so let's use that. Okay, you have to keep in mind that they're odd. You have to read the problem carefully, right? Consecutive odd. But since there's 4 of them, if you divide 104 by 4, you get 26. Now, 26 is not an odd number, right? No. But now you can guess numbers around 26, right? So you could guess like 23 plus 25 plus 27 plus 29. And let's say you didn't guess that right away. Maybe you guessed 25 plus 27 plus 29 plus 31. When you add these up, all right, you get 112, right? Well, that's too large, so maybe you go down a number. So maybe you go down to 23, like I said. So again, dividing by how many numbers you have to keep in mind whether even or odd, but it gives you a starting point where to guess numbers. It's not always the answer, okay? But that would be using a strategy called guess and check. All right? So we did it 2 different ways for you. Great. Let's move on to example 5. So example 5 is one of those good problems again. It's a comparison problem. The cost of a pair of silver earrings was $15 less than 3 times the cost of the gold earrings. That's a pretty important sentence. Combined, both sets of earrings cost $341. So that tells me that if I add the gold plus the silver, that equals $341. And it's really helpful to always make representations like this. Now find the cost of the set of each set of earrings. Excuse me. So we got to find the cost of each one. So off to the side, let's label gold and silver. I want to represent those two algebraically. Now it says the cost of the pair of silver earrings was $15 less than 3 times the cost of the gold earrings. Okay, so the silver earrings are are described based on the cost of the gold. So we know a little bit about the silver. It's everything I just circled, but we don't know anything about the gold. So when you're doing these comparison problems and there's one item you don't know anything about, let that be your variable. So the gold earrings are going to be X. Okay? So gold is X. We're going to use X to represent that. Now the silver earrings are described based off the cost of the gold and using the cost of the gold. So it says $15 less, so that's minus 15, then 3 times the cost of the gold. Well, if the gold costs X, 3 times that would be 3X. Now remember, you still got to take away that 15. So the gold is X, the silver is 3X minus 15. So again, when these comparison problems, you're going to have 2 physical variables in your problem. Okay? So here's the gold, here's the silver. We can add those together and solve it. So we get 4X, this is the easy part, minus 5 equals 341. And I'll continue down here, add 5, 4X equals 346. Divide both sides by 4. And actually, while I was solving this, and this is something that could happen, this is good, I noticed that. If you look, it was actually 15, right? So I wrote a 5 there. But that will make sure we get the right answer. So let's fix that. See, even math teachers make mistakes. It happens. But now we add 15 to both sides, right? So we get 356. Now we can divide that by 4. X is 89. Okay? Now, remember, we have to find the cost of each one. This is why this labeling is so helpful. We use X to represent the gold. So if the gold is X, that means the gold costs $89. Now maybe this is cheaper gold, maybe like 24 karat or not real, not the good gold. So it's $89. Now we take this amount and plug it right in there. Okay, so 89 times 3 is 267, right? And then minus 15 for your final answer for the silver, and it costs $252. Okay? So we label it because it's money. And just to check it, if we add 252 plus 89, we do get that total cost of $341. So the gold cost $89, the silver cost $252. Okay? So again, this is a great comparison problem. Let's do one more problem, and we'll do one from your homework. I love that example 6. More of an advanced problem. That one could also be solved using a system of equations, but we'll come back to that maybe on another day. Okay, so I'm going to do this number 7 from your homework. So Ming Lee spent $10.20 for a pizza and a soft drink. So that would mean pizza plus soft drink, and this is where a separate sheet of paper is helpful, equals $10.20. If the pizza cost 11 times as much as the beverage or the soft drink, how much was each? Well, the pizza cost 11 times the beverage. So we know some information about the pizza, right? But we don't know anything about the soft drink. So since we don't know anything about it, the soft drink is going to be X. Therefore, the pizza, if the pizza cost 11 times the soft drink, it's going to be 11X. Okay? So now we could do the pizza, which is 11X, plus X, equals $10.20. Okay? So now's the easy part. Combine like terms, you get 12X equals $10.20. Use your calculator because you can definitely use your calculator. Divide by 12 here. X equals 85 cents. So we'll write that as dollars because everything was given to us dollars. So 85 cents or $0.85. So now we could either take that, so the soft drink cost, I'll label over here. This is why I love this, by the way, $0.85. We could either plug that $0.85 right in there and times it by 11. Okay? So if you times $0.85 by 11 in your calculator, or by hand, you get $9.35. Or anytime you're dealing with two things, you could just take that $0.85 and subtract it from your total. That would also give you $9.35. So the pizza cost $9.35. The soft drink cost 85 cents or $0.85. All right? So that's another comparison problem for you. Okay, one more problem. This lesson's a little bit longer than I like to usually have, but it's so important that you see some good examples. But I definitely want you to try this one on your own. So the sum of 3 consecutive even integers is 144. What is the difference, that's an R there, what is the difference of the largest integer minus the smallest? So the hint would be figure out this first part. Figure out what your 3 consecutive even integers are. So pause the video and try this one on your own. Okay, so hopefully you tried this on your own. If you didn't, pause the video and try it on your own. So I'm going to solve it using algebra. So they're even integers. So I'm going to let my first one be x. Since they're even and odd integers both increase by 2. Like 2, 4, 6, 8. So my next one is going to be x plus 2. My third integer is going to be x plus 4. It's going to be 2 bigger than the previous, 4 bigger than the first. So I'll take those 3 integers and add them together. Set that equal to the sum which is 144. So when we solve this is the easy part, right? First integer, second integer, third integer. We get 3x plus 6 equals 144. Subtract 6. 3x equals 138. Divide by 3. $46, right? So the first integer is 46, the second integer is 48, and the third integer is 50. Let's check it to make sure. If you add these up in your calculator, you do get 144. So now we can answer the last part of that question. What is the difference of the largest integer minus the smallest? It's actually easy now, right? Here's the largest, here's the smallest. So 50 minus 46 is 4. That's actually our final answer. Okay? So you can see after all that, the meat was in solving this, writing the equation and solving it. But once we got all that and figured out what our three integers were, answering that last question was pretty easy. All right? So thank you very much for your attention. And by the way, you could have also used guess and check for finding the consecutive even integers. Okay? If you divided 144 by 3, that'd give you a good guessing point. But thank you very much for your attention. Hopefully you found this video lesson helpful. If you have any questions at all, please let me know. Have a fantastic day.